Assalamu alaikum. So this is the second session of our secondary data analysis. In previous session, we have discussed how to download data from GBD. In this session, we will discuss how to analyze those data which we have downloaded on R. In GBD data, first we have to select the topic. Then for that topic, we have to select which type of visualization and tables we want to make. Once we decided that, then we will do analysis on R. In this session, we will discuss the analysis on prevalence of ischemic heart disease. I have made all the codes for the analysis, and we will start from those analyses. Okay, first in R, when you open the R script will show nothing here. The main region where we run the code is this area console. So in this area where the plots are written, file plots, packages, and other things. So the plot there here the plots will appear. So we will create our code, which I have already created for my data. When we are doing the analysis, we have to load the libraries which we want. Like in this analysis, I am going to make the tables for prevalence change and EAPC, estimated annual percent change for prevalence data of ischemic heart disease. So I will load the dplyr library, tidal library, broom library, and this library, the read Excel library, is to load the Excel file from our computer. Like we are loading an Excel file. Here we will go to import dataset from Excel, and then here we'll go to browse. Then we will locate where our data is present. Like this is my data. I am going to load global PID main regions, PID, SDI, and WHO PID. These data I will load. When I am loading the data, I will load the data one by one. As in R, we can't load all the data by once. I have already told you in the previous session that we will download every data separately. Like you are looking, the global PID is separate. Then for the countries, it should be one, but the GBD give me all the data separately. Now this will be separate. The main regions, risk factor for STI will be separate, and WHO risk factor for separate, and these are separate. So I'm going to load the global for this analysis. I'm going to load the global main regions and SDI PDI. So I will click on the global. Here it will appear, and on the library read Excel, it will be imported to or like you can view it here. This is the global PID data. Okay, now I will load these three libraries directly from here as I have written their code or location. Like you can see, it is in the folder D, then in the GBD, then in research, GBD research, then in HME file, ischemic heart disease, Excel, and PID main region. All these data are present inside the D in my computer. I will load it directly here. Once it loaded, then we will decide whether we have to merge the data or we are doing the analysis separate on each data. As I am doing the analysis on all the data, all these four data, because I am going to create the table for prevalence, percent change, and EAPC. So I have to make these all data bind. So the code is, this is the data name, then this is the function. Bind row is the function, and this is my data like global PID, and here you can see global PID. Then you can see PID SDI, and you can see the name PID SDI. Then you can see WHO PID, and you can see my data name is WHO PID, and the other is PID main regions. I have already done it, so I will just run the code. You have to change the data names for your files. This is my data. I'm going to do it on my data. Okay, now this is the code where it started, the prevalence data. This is the data by which I will be doing the analysis. Like here I will write my data, whichever your data is, whichever your data name is, you will write it here. I have written all data because my data name is all data. So I will run this code, and in this data I am working on prevalence. So the prevalence is here. Now I will run this code. Now I am working on cases of data and rate data. So this is the name. This isn't a function or a code. Actually, the code is this. So in this data, you can see it have taken the number from the data, and here it have taken the rate from the data. I will show it in the data to you. Let's do it. Okay, this is my data. You can see here in the metric name, this is number, this is percent, and this is rate. Now I am working on rate and number. So I have selected the rate and number in my code. Like this is the number and this is the rate. These two are separate codes and you can run it together. Now this is the percent change calculation code. This code calculates the percent change for your data from 90, how much percent is changed from 1990 to 2021. Here we are using the case data like this one. And in the another we will be using rates, which will be coming as on the, okay. Now this is another code for calculating confidence interval. Like I have done this on case data, so that this code is also on case data, like the number in my data. Now this is the code for the rate data. You can see here that the rate data is given here. Now this code is for EAPC calculation, so we will run this code. This is just a calculation code. No, there is no data name entered here. As you can see, there is no data like rate data, case data, or all data. No data here, but it is just a code which will be used in the following codes to calculate the EAPC. So here, EAPC out, which we will be doing for rate data. You can see here, this is the rate data, and UAPC will be calculated on the above code. In this code we have calculated. Now all the analysis is done for formation of tables. Now I will just make the table like EAPC calculation is done, percent change calculation is done. Now I am doing this, running this code to show the table or to make the table. So the table is made. You can either view it on front or use the view function to view it in the script. Now this is the table R has given me, like these are the location names. As you can see, these are the main regions. Then these are the SDI. This is the global, and these are the WHO regions which I have used In my data, all data like WHO regions, SDI, main regions, and global. And here you can see the percent change for 1990. This is the 1990 cases, 2021 cases. The percent change is here, and here 1990 rates, 2021 rates, and EAPC is given here. You can then download it by loading a library called Write Excel. When you enter it, just don't worry about the warning sign. It is just telling that it is built under R version, but it's working. So now I will enter this code like the final tables as I have made here final tables, and it will be downloaded on the name of IHD prevalence summary. So if I run this code and I go to my documents, you will see here the IHD prevalence summary, and this is the data. You can then upload it in your study. Okay. So you see the percent change cases 1990, 2021 cases, 1990 rates, 2021 rates, and EAPC. Now we will move to our next step by plotting visualizations. These are some of the codes which are used for plotting visualizations for prevalence data. So the first code is this one, and this is for the visualization of percent change and EAPC. So first of all, we have to decide for which data we are doing the analysis, as we have done in the previous ones. So these are the data. I'm going to load the data first. Data is already loaded, but let's confirm it. Once the data is loaded, I will do the analysis for only PDI, SDI, like prevalence, dailies, and incidence for SDI regions. So our code starts from here. This is the prevalence data which will be calculated or filtered from the SDI data. This is the incident data filtered from the SDI data. Similarly, dailies data from the PDI SDI data. So I will run this code. As you can see here in this code, only prevalence is taken from the column measure name. You can view the data, the column name is measure name, and then the data which we are taking is only prevalence. So then the next is measure name and incidence, similarly measure name and daily. Now we will calculate the percent change for prevalence data, incidence data, and dailies data. Here in this data, we are using this data, prevalence, prev data, INC data, and dailies data, because we have filtered the prevalence, incident, and dailies into this data. Now we will not use the PDI SDI data, as in this data all the measures are given, but in this data only the prevalence data is given. Similarly, in this data only the incident data is given. So for the prevalence change, prevalence percent change, this is the code. For incident percent change, you can see incident INC data. Similarly, for dailies percent change, you can see the dailies data is given. I will run the three codes. When the code is done, you can view the data for the percent change. Now we will come to the prevalence percent change. So this is another code to mutate it for our visualization, and this is the code for percent change to combine all the prevalence data, incidence percent change, and daily is percent change. Now this will combine the data. So once this is done, we will prevalence change. We are just changing the A percentage change to percent change as it you can see it in here. View it. Okay, there is an error. So let's go forward. Now here the column will be changed to percent change, and then we will make it as a factor. And in the next code, we will run the code and get the results. So there is a change in somewhere in this data. Like, okay, I didn't run the library. So for viewing or for making plot, for making visualizations, we have to run the ggplot library. Then the code will work. Otherwise, it will not work. So this is the data. You can zoom it in here. You can export it from here. Save as image, save as PDF, here, whatever you like. Then in the directly in which location do you want to save it. I have already saved it in here, so no need to save. And you can also change the name in here, that this is the percent change data, or whatever name you want to give this. Okay, now come to the percent change. The percent change is start from here. We will just run the code. These two codes are similar, so I am removing it. Okay, now these will calculate the codes, the EAPC data, and this will make it for visualization. So this is the EAPC. We are now binding the EAPC data like EAPC preview, EAPC preview, EAPC incidence, EAPC incidence, EAPC daily, and this is the function for binding these data. So bind it. Now this is the code to rename the column for EAPC. When I am running code in the R, I am pressing Control and Enter. This is the simple way to run the code. Okay. You can view the data here. Now we will come here to show the data. As you can see in here, this is the EAPC all one. In here, this is the EAPC all one, because I have made this data for visualization, and only this data will work for visualization. Then the X is the value, which is the value of the prevalence, incidence, and dailies. This is the location name, which will be on y-axis. You can see it here. You can see the value on x-axis. This is the value of percent annual estimated annual percent change, and then these are the colors which are given to these. So you can then save it as previously discussed. Okay, now you can also do this for WHO data, like just change this into WHO, change this into WHO, change this into the WHO, and then run it. Below this, when you change these three areas to the data whichever you want for visualization, in the below data there is no need for the change of data. Just here we can put the data and then we can do the analysis. But It's according to your data. If your data in this code, if your data is from 1990 to 1919, then it won't be 2021, it will be 2019. You can give this code to ChatGPT and then tell them what I want for my data or which variables are in my data. Just change the code, it will change it. You can also give the ChatGPT a visualization of this picture or another picture, whichever visualization you want, and tell them to give me the code. But the code is a rough one. It will give the codes, but the code will be rough one, and these codes you will make changes to the codes according to your data. Like in ChatGPT, it will give the location name is region, then you will change that name into your according to your data name, like location name. Okay, now coming to another codes. Now coming to the next step. In this step, we will create the bar plots for the prevalence data of 1990 and 2021. In this data, we will be using PID global, main regions SDI and WHO. I will just copy it here. Then I will bind it. Once the data is bind, then we will be doing our analysis. So this is the last data. And now we will run this code, bind this data. Now the data is bind. In this data, we will, in this code, we will be only taking rate of which measure prevalence. And the year will be 1990 and 2021. The other years will not be included in this data, in this code. So the location name, year, value, upper and lower value. So this is the plot data then. Now I have added this code to order the location names. Like if I am not using this code, then it will give us the location names in this y-axis, which I don't want. So I have added this code to give me the location exactly like I want. So now this is the plot, but first we will use the ggplot library to make it. Now this is done, and now I will print the plot, and you will see it in the plot area. So this is our plot. You can zoom it. You can change the color from green and orange like in the global data. As I have told that the custom, I have made a code which make the data as the global is first low SID. You can see it here, low SID, low middle SID, then there is low middle SID and so on. So the the prevalence rates are in 2021 is the green and 1990 is the orange. 1990, the rates were high, and in 2021 now the rates are low, but in the low SID, the 2021 rates are higher then the 1990. This is another code. So now we will be doing another code for this, another visualization. Okay, now let me first review it. Which type of code is this? This is a line plot of prevalence rate. Okay. So I am using only SID data here. So I will only copy this data and paste it here. So it will take the measure name as prevalence and the metric name will be rate. We will not be using number or percent in this visualization. These are the colors. These are the shapes which I want. And now this is the plot code. Now the plot data is not found, so we will be okay. Let's load the library again. View plot data so we can. Okay, now the plot data is made. Now we will adjust the colors and shapes. And then this will be our plot. So you can see it in here. These points are the years, like 1990 is the year. Then this is 1992, I think, then 1903, 4, 5, and so on. So this is, here you can see, this is the shape of high middle STI, this is the shape of high STI, and so on. These are the years, these are the rates, and this is the data on each year. Now coming to our another data. So here already the code is given that I am using global PID, SDI data and WHO data. So I will just run the code. In here I have used the number and for all ages, and then the location names are these. Now this is for age groups and this is not for age, it is just for all of the data. So I will just first I will do on all ages and then I will show you how to do it for age groups. So this is for all ages. Okay, the error is that these colors allotted to the plot is limited. As you can see it in region of the America, there is no color, only there is a line. So you can add a custom color here for all region, then it will be okay. So, okay, now do it for the age groups. Now it is for the age group. Now this is another code for the age group. This is another code. And the last one is for the age group. So this is the plot for all the age group. Like you can see the 5 to 14 year is blue color and the red is 80 and 80 plus, and you can see it all the color in here. You can change the codes according to your data. I am telling this again and again because This is data for my study, and you will use your data names for your study. And then the number, this code is universal for GBD data, so there is no need to change the number and all ages and subgroups. So just you have to change your data name. Like this is my data, bind data is my data in which there is global SDI and WHO data. So you can use your data and run the code. Okay, now this is the 6 number code. In here first we will load the libraries. Then in here you can see that there is a migraine data, but I don't have migraine data. I only have, okay, these are the heat maps. Let me first check the code that for what type of data this code is. So okay, now I will be using it for SDI data. So you will change the name here. Rest is the same, but you will remove this, or you will change it to both, because in my data there is a 3 types of sex name: female, male and both. I am using it for both, and you can also remove this, there is no need for this. Now when we run the code, now here there is no need for changing the data name, as this data filter is already done by the PDI SDI, so it is okay for me. And now this is the ggplot for this data, and this is the heat map according to the SDI locations and years. In each year it have given like 1990 to 2021. You can wide it to see it clearly. Like these are the percent or rates of prevalence, percent of prevalence in each area and in each year. Now this data is done by for all ages. Now we will come for age groups. So I will change the data here, then we will run the code again. I will change the female to both, and remove this as I don't need it. And now the following codes are good for me. So just run the codes and you will get the plot for the age groups. Like you can see it in here. These are the age groups 5 to 14 and 80 years, and these are the years, and the colors are for the prevalence percent. Like red color is for 15%, then the orange is for 10%, and so on. Now coming to another data or visualization code. So this is the code for another visualization. You can see it here. I am using the rate, sex name both, and prevalence all ages, and I will be doing it for SPI. Okay, the name is incorrect, so I will change it, as the name I have given to the data is PDI SDI. Okay. Now the problem is that I have selected wrong data. I will just load the data from here. as I have already done here. I will also show how to merge these data, PDI with SDI. I have already merged it, but I will give the code to merge a data with SDI values. So this is the data I have already merged, and now I will be using this data name here, so the rest will be fine. Now these are the location names filtered. Okay, I will again enter it, and I will give the shapes and colors to the values which I want. Then this is for computing correlation, and this is for the plot generation. So you can see the plot. It will take some time, and then it will give us the plots. So this is our plot. It's not working in Zoom, but I have to mention some of the things here, because there are things like we will be using the metric name rate, the sex name both in the major name prevalence, and the age name all ages. Because if we didn't give the age name or the sex name, then it will give us this plot for all the ages and it will be too overloaded. So I have done like this green color. Okay, the green color is for Eastern Europe. Okay, now this color is for Eastern Europe, and it is for only for all ages group. Like if I have if I didn't add the all ages age name, then it will give me, like you can see it in here in this data, the ages are, it will give me less than 5 years, then it will give me 15 and 19 years, and this plot will be too overloaded. So I have converged it to only all ages. Now this is a code for Chloropleth data map. So I will be loading the data here. I only load one of the data. There are 5 datas with me. It will take some time. I will stop recording so that I should minimize the time. Okay, I have loaded the data. Like these are the 6 data for all the country. As the GBD data didn't give it me in one file, so I have to bind the data. So with this code, I will bind the data on bind rows function. Like this is countries 1, countries 2, countries 3, and up to countries 6. Just control and enter, and it will run the code. So now in bind data, I am using only the prevalence measure name. So I will filter the data for the prevalence. Now I am looking for the percent change, because on the countries level, I am looking for the percent change of IHD. So I will run this code, and the percent change is from 1990 to 2021. It will be using only these 2 columns of the years: location name, cause name, year, and then the value. So enter it. Okay, first load all the libraries, because these libraries will be used here. Map data, name data, and then these 3 libraries. If we didn't run the country code maps and maps data libraries, then the Chloropleth map or the world map won't be made. Now coming to this. Now in here, it will allocate the country code to the data. Like I will view you to the bind data. You can see it in here. When the code is run, I will show you that there are no country codes from the libraries in this data. So in this code, we will be allocating the country codes and the ISO 3 codes to the data. As the data is big, so it's taking some time. Let me just stop the recording to shorten the duration. So this code is taking a little bit longer time, so I have removed it. We will move to our codes. I will be running this code. This warning is okay. It says that some of the values are not given correctly because some of the values are missing. So we will view the prevalence data. Now I was telling about the previous data. In the bind data, the location name, class name, and percentage, and these three are given. But with this code, the three others columns are given, like ISO 3, region, and measure is also in the previous data lake. But these two columns are given by this code, which we have run recently. Now, these are the colors for the countries. Like if I have a prevalence percent change of less than 0% and equal to 0, so the color will be gray 80. If it is up to 20, the color will be blue and so on. You can change the color in here, like if I am changing this to a light blue. So it is blue. Now this is also blue. We will be giving this green color. Then this will be brown. This is orange and this is purple. You can change the colors as you want. So I will run the breaks, labels, and colors codes. Now, okay. Now I will calculate the percent change for it. You can also view the percent change now. The map code to assign all the countries with their respective prevalence values. And in the last, this is the code for visualizing the map. So this is your data, this is your visualization code, and the visualization is given here. We can see the colors like green, which we allotted to which for 21 to 50%. Then these are the missing values. The gray are the missing values, as you can see here in the code. If there are missing values, the color will be gray 90. This is for that purpose. And all the countries are colored with their respective names. So after this, we can add the title to this. You will see here in this code. Okay, let me just enter this code. So these are the percent change legends which are given here. And in this code there is a little bit problem, but we can make it by ChatGPT to align it with our data. And year maximum, but in our data there is no value such as year minimum or maximum. So I have changed it to 1990, which is the minimum year in my data, and then 2021, which is the maximum year. So when I run this code, you can see that the head of the data is here. Now, I told previously that I will be showing you how to merge two datas, especially the SDI data and the other one, PID main location. Okay, now in this code, we have to load these libraries. If these library are installed in your R, so first of all, you will install it on install dot package, and then you will write whichever library you want to install. When you run this code, the package will be installed. It is already installed in my R, so I don't have to reinstall it. Okay, there are two datas. Like one of the data is these two are my datas, which I have already loaded, but let me show you. This is one of the data. Control enter. This is the second data. And then I want to skip the first column as I don't need the first row because it's changing my. So the first row is changed. Okay, there's PL. Okay. And now I want to change the columns names of STI data into location name. I can show you that in this data, the name of the column is location. So I have to change it to location name. So this is the code for it. Just enter it. Now, in this code, we will now be rearranging our code to merge the data. You can see here, this is the main regions data. This is the SDI values data. So with this code, we can join the data. And now this is the mapping table. In here, in this code, you will write these according to your data sets, like IIPID location, which is in here, and this PI locations data, which is in here. I made these two days data from the above data uploaded. So after it, I will run this code, and after it, I will run this code, and so on. And the last, I will get my data with which I have done an analysis already. I have done an analysis for it. You can see it here in this data, the SBI values have come here for different region in different years. I will show it here. I've already downloaded it, so you can see it here. Like this is the SBI data which isn't merged yet. So in this data, you can see these are different years. These are SBI values for countries and main regions. Then I have merged it with this data. Here in this data, you will see that there is no value of SDIs to the countries or the main regions. There is measure name and all these, but there isn't any SDI value. So when I merge this data, you can see it in this data which I have already downloaded. All the data are given. Let me just fix it. Okay, this is the data. So this is the main region data, and this is the SDI values added to it. Like North America in 1990, the SDI value is this. When in Central Europe, the SDI values was this in 1990, and so on. You can get all the data if you want. So this is all of our session. And hope you will enjoy it and learn from it.